Hello guys, welcome back to my YouTube channel. In today's video we are going to solve some examples on Lambert function. Okay, so our first example will be if we have x power x equals 4. From this you can just write 4 as 2 raised to the power 2, and by comparing you can just say x is equal to 2. Okay, so we want to solve it using Lambert function. So our first thing that we gotta do is to take the natural log on both sides. Then this moves to this side, so we get something like this. Okay, now remember that x is the same thing as this. I've already proven this. I've already told you the reason why this is the same thing as x. So we get this. But then 4 is the same thing as 2 raised to the power 2, right? So it's the same thing as 2 ln of 2. Okay, so we can take the product log on both sides because we've met our condition. That's this is the same thing as this. So these two can also be written as this, right? So multiplying ln of 2. This whole thing reduces to this. Now this is also in this form, so this is the same thing as ln of 2. So you see we've gotten it in this form, which makes the solution quite easier. So taking the antilog on both sides, we get x equals 2. Okay, so our second example will be this equals 2. Okay, you can pause the video and then try this out. So we have this equals 2, taking the natural log on both sides. Now this whole x squared is representing the exponent, so if you had to move any term to this side, then it has to be the x squared term. So we get the x squared multiplying natural log of x equals natural log of 2. Okay, so the x squared can be the same thing as e raised to the power natural log of x squared. Okay, then these two can be transferred to this side, giving us e raised to the power of 2 multiplying the natural log of x. So we can rewrite this x squared as e raised to the power 2 ln of x multiplying ln of x equals ln of 2. Okay, now we must get it in this form. That's the term here should be the same thing as the term here. So this can be written as ln of x multiplying e raised to the power 2 ln of x equals ln of 2. Okay, so by comparing these two terms, we can see the only difference is these two over here. So we want to make this one also a 2 natural log of x, right? So this one we have to multiply both sides by 2. So multiply this side by 2, then this side also by 2. So we get 2 ln of x e raised to the power 2 ln of x equals 2 ln of 2. Okay, so from here we can just take the natural product log on both sides. So we get 2 ln of x equals product log of 2 ln of 2. So it's just like in this example. These two can be written as e raised to the power ln of 2. So multiplying this ln of 2 that we have over here, so we have something like this. So this is the same thing as this. Okay, so that means this whole thing is going to give us ln of 2. Right, so we have 2 ln of x equals ln of 2. We want to make x the subject, so divide both sides by 2, they cancel out. Ln of x will be equal to half multiplying ln of 2. which will be the same thing as ln of 2. We can transfer this half to this side. Raised to the power half, the same thing as ln of, anything to the power half is the same thing as square root, so we get ln of square root of 2. Okay, so we have ln of x equals ln of root 2, and taking the antilog on both sides, we will have x to be equal to root 2, and that will be our final answer. Okay, so yeah, that is it. Moving on to our next example. Okay, example 3. Let's assume we have 3 power x equals x plus 1. Solve it using Lambert function. Okay, so if you can clearly remember, this is in the form of a power x equals bx plus c, right? In my previous video, we solved a question in this form. I don't really remember whether it was the same thing as this, but it was in kind of form like this, right? We made x the subject from this equation, so we are going to use that same method, that same procedure to do justice to this question. Okay, so our main focus is on this exponent over here, right? Now the exponent here is x, it's raised to the power x, right? The term over here is x plus 1, so we have to find a way to make this exponent here x plus 1. So what do you think we should do? That means you have to multiply this side by 3. It's the same thing as 3 raised to the power 1. Because they are of the same base, and per the laws of indices, you add the exponents, giving us an x plus 1 as the new exponent. So because we multiply this side by 3, you have to do the same to the other side. So we get 3 multiplying x plus 1. So the same thing as this. Okay. Now, this is how we are going to do next. We are going to divide through by 3 raised to the power x plus 1. Okay, so they cancel out. We are left with only 1 here. Now, this can be written as 3 multiplying x plus 1. The multiplying, we want to transfer this whole thing to this side, so the exponents will change to a negative. The whole of the exponents will be negated. Like if you have anything in this form, it's the same thing as this. Okay, so 3 raised to the power negative of x plus 1. Okay, we want to get rid of this 3, so we divide through by 3. They cancel out, so we have 1/3 equals x plus 1 multiplying 3 raised to the power minus x plus 1. Okay, so our next step will be manipulating this thing. We want to introduce an e based on our principle. We want to introduce an e, so we do that with this term over here. Do that with that thing. Okay, so this can be written as e raised to the power the natural log of 3, or raised to the power x plus 1, negative of x plus 1. Okay, then this can be transferred to this side, so we get e raised to the power negative of x plus 1 ln of 3. Okay, so this is it. Now we just have to compare both sides, both terms. This term and then the exponent over here. They should be the same thing according to our principle. So we have negative of x plus 1 ln of 3, but this term is only x plus 1, so we just have to multiply through by minus ln of 3. That's all. So we multiply this side by minus natural log of 3, so multiplying 1 over 3 equals, so this side becomes this ln of 3 e raised to the power minus this, then ln of 3. Okay, so we now have equal terms, so we just take the product log on both sides. Alright, so this whole thing reduces to this. I mean, we just take either this or this, and they are the same, so we just take one of them. This can be written as minus 1 on 3 ln of 3. Okay, from here is just basic math as usual. You have to make x the subject from here, so we can divide through by minus ln of 3 so that they cancel out. We get x plus 1 equals minus 1 over ln of 3 multiplying the product log of minus 1 on 3 ln of 3. Okay, so x will be equal to, just subtract 1 from both sides, so just move this one to the other side. So positive crosses the equal sign to become a minus, so we just put like this. Okay, so this will be our final answer for this question right here. Okay, so let's deal with our last example, then we call it a day. Okay, so our last example, number 4, we have this x power x all raised to the power of x power x equals, let's say, just picking a random number, let's say 5. Okay, so you can try this question out. I mean, pause the video and try this question out. So in order to make this one very simple, we have x power x multiply another x, raised to the power another x power x. So we are going to represent x power x with an a, so we get this equals 5, and we've already solved the question in that form. I mean, that was our first question. Okay, so if you have a raised to the power a equals 5, I mean, just like the first example, take natural log on both sides, changes to this form, then we get this. I mean, the a is the same thing as this, equals this product log, we get this equals this, then a will be equal to e raised to the power of this. Okay, so this is a, but a is not what we are finding. A is equal to x raised to the power x, so it gets x to the power of x will now be equal to this. So it's just the same procedure from here to here. Use that one to also solve for this one. So we get, take the natural log on both sides, e w 5. This one moves to this side, so we get this x ln of x equals, this one can also move to the other side, so we get this. But I know the natural log of e is the same thing as 1, right? Base the same thing, so it's just 1. So we get this equals product log of 5, because the whole of this is 1. Okay. Okay, so proceeding, we rewrite the x as this, equals this product log on both sides. Okay, so you see in this question we will get 2 product logs. Okay, so we get natural log of x equals product log of the product log of natural log of 5. Okay, so we're making it the subject. X will be equal to e raised to the power, this whole term right there. Okay, and that will be our final answer. Okay, so thank you for watching. In my next video we will talk about a different thing altogether. So this is where I would like us to end with the Lambert function. So we handle Lambert function with this video. Okay, so in our next video we'll talk about a different topic altogether. Okay, so thank you for watching, and please do well to subscribe and like for more videos. Okay, all right, thank you for watching. I'll see you in my next video. Goodbye.